CSIS 1550 is filmed before a live studio audience.
So let's sort of recap briefly. The other day we talked about the idea of, as a control freak, we want to make sure that we control the data. We want to make sure that we know that we're responsible for it. We want to have more security and so on and so forth. So we looked at dealing with views as a minor way to control things. And we looked at making users, right? And a user, obviously, that's the ultimate control because you give them what privileges they're allowed or what they're not allowed, right? And so you have a lot of control over that. But we write our own queries. We also give permission to users. And we also, potentially, you or the other programmers will write code that will write queries, right? If you're writing code that writes queries, you need to give the code a username and password. Give it the most restrictive one you can give it, right? So, because it's still a user, right? All right, but we're going to move on and do part 2 of it, of Control Freak, where we talk about indexes and constraints, all right? So think about an index. When you look in a book for a particular topic, let's say we're looking in our textbook for this class, and we decided we wanted to learn about joins. We could flip through the book and hope that the word join sticks out somewhere, right? And stop and read about it. Or maybe we can open up the table of contents and sort of scan it and hope the word join sticks out. Well, what's the ideal way, obviously? Look in the back of the book at the index, right? Look up the word joins, and what do you see? You'll see something like this. Joins, and it'll be like, page 44. I don't know what pages it's really on. 90 and, whatever, 27 through 36, whatever. It'll look something like that, right? And so what do? Right there at your fingertips, you have access to exactly where this stuff is at. Okay, well, we're going to create indexes on our database that do basically the same thing, right? Why would we want to do that? Say it again. So you can find stuff quicker, more easily, right? Yeah, so let's take a look at in the database right now. I think I have it open already, didn't I? Yeah, there it is. Let's go to Colonial. Use Colonial. And the trip table, select star from trip. So here's a list of all the trips that this company has and that they track. There's only 41 records. Not a big deal. But in the real world, this might be hundreds, thousands, hundreds of thousands of records. I want a list of, select star from this where state is equal to Vermont, right? That's what I want. Well, that only took 0.001 seconds, not a big deal. But what if I had tons and tons of records here? This could slow things down. So if I wanted to, I can put an index on the state field, and it would do something like this. I'm going to tangent here and show you a really cool kind of query that we've never looked at before that will give me some information that I need to help me show you what an index looks like. This query has nothing to do with indexes, but it's just a way to save me from having to write down a bunch of stuff. And I use this when I need a list like this. This is a good choice. So it's called the group concat function. So group concat. So select group concat state from trip, all right? This isn't quite the full information that I'm looking for, but this is a cool query. Again, this has nothing to do with indexes. This just has to do with the way to make the data to be displayed a certain way, and you'll see why I'm doing that in a minute. But check out what this does. It gives me a comma-separated list of every single state all in one column, right? That can be very useful for just quick little things that you might want to do. And so I want a distinct list. So I'll do that, and that gives me a simple list right there, right? Well, what I really want is the IDs for each trip. I want to know which IDs belong to New Hampshire, right? Vermont is ID number 2, and trip number 3 are in Vermont, and also trip number 20. So I'm just going to make a quick query that will pull that data out for me, just for this sole purpose of showing you sort of like an object lesson, right? So what I really want is group concat unique state, and I'm going to put a little concatenation here of a colon after it, and then group concat trip ID. This isn't quite the whole query. We need to do one more thing. But look what this gives me. It gives me a list of all the states with a colon, because that's exactly what I said to put there, right here, right there. And then it also gives me a list of all of the IDs. Well, what do I want to do? I want to actually group it by the state. Does that make sense? Okay, so I'm going to do just a little group by here, group by state. So now this is what the query really is saying, right? Select group concat distinct state and group concat trip ID from the trip table, and then group it by state. So this will give me this. Now, what does that look like to you? The index in the back of your book, right? So this is not, we did not just index a table. That's not what's going on there. This is just me writing a somewhat cleverish query, not Cleary, that's an author, somewhat cleverish query to display roughly what an index sort of looks like, right? And so I'm just going to copy and paste this into a text editor so we can have it as a reference. That was the reason I did that. All right. And I'm just going to leave, I guess I'll leave those weird names there. That's fine. So here's the idea. We're about to create an index in our table that will say, if I say select star from trip where state is Connecticut, it only has to search through 5 records. And there they are right there. This little thing I just built, something roughly like that will be in the background behind the scenes that we'll be able to query from, right? And so if I wanted to find all the places in Vermont, select star where state's in Vermont, and it'll immediately go to that 5th record there. You'll only have to search through the other 4 to find it. And then it'll go, oh, you want Vermont? That's 23, 2, and 31. Let me grab those for you. And it'll be so much faster. Now, we will not notice it here with our teeny little silly database, but in a big database, I've actually had scenarios where we had queries that would take probably a half an hour to run, put an index on the one field, and suddenly they're running in, a second or 2, right? So it makes a huge difference. So let's do the index, and then let's see what's going on, okay? So I'm going to move that to somewhere else, I guess. All right, so we're doing structure here, where I'm altering the structure of a table. So what's our little mantra that we do? Say the thing you're going to do. Say the thing you're doing it to. Say its name.
Say my name.
State, index, or chicken index, whatever you want to call it, make up a name. And then we want to do that on the table called trip, and specifically the trip ID, right? That's the form there. Now, if I wanted to, it's going to do it right now alphabetically in order of state, or sorry, excuse me, state. That's what we want to make our index on, not on the trip ID. Okay, it's going to do it alphabetically on state, or I can do it descending like that, and it'll sort it alphabetically. But what's happening is it's essentially making something kind of like this in the background behind the scenes that we can't see, and it's a sorted little list of those 5 records. There's those 5 states and the IDs that they match to. So now when we run this will create a little index. We've created an index now, and so if I describe this table, describe item, what am I talking about? Describe trip, I don't know where my head was there just now. You can see right there on the state field, there is a thing in the key here. It says MUL. What do you suppose that stands for? Close. It does stand for multiple values. So we don't want a state field you can't have duplicate values in, right? You can't have 2 trips in Vermont. Well, we don't want that. So this will allow multiple values, okay? So this little thing here was just a silly query that I wrote just to demonstrate what the index might look like. But somewhere in the background of this database now, there is some sort of table that looks kind of like that thing I've got highlighted on the screen there. Looks kind of like that. And whenever I do this query now that says select star from trip where state equals Connecticut, then it went and looked in that table that was up here, this table up here. It looked in there, it found that Connecticut, it was the first record it came to, so immediately it found Connecticut, and it said, oh, you want ID 7 and 19. So that was the same thing as if I somehow magically knew that trip ID is in 7 and 19. But I use that little index to help speed things along, okay? You can also create an index that won't allow duplicate values, right? This one will allow multiple values, obviously, because it's a state. But you could do one that won't allow duplicate values. So for example, let's go to the TAL database here. So let's look at the customer table here. And we don't want to allow people to reuse that name. So we're going to create a unique index that says you cannot, if Toys Galore exists, your company cannot be called that. So create unique index, right? Say the thing you're going to do, say the thing you're doing it to, say its name, right? And the name is, I don't know, we'll call it customer name index, something like that. On customer name field. Right? Does that make sense? Now, if I look at describe, it now says that it's a unique key. If that's a unique key, what does it suddenly become? Think back to our days of, it's not the primary key, but not a foreign key. Candidate key. Oh, okay. Yeah, like a candidate key, right? It's a candidate key, not a concatenated key, but a candidate key. So because I cannot enter a duplicate value, now everything is functionally dependent on customer name, right? Where it's still not being used as the primary key. We're using customer name as the primary key, but this is now a candidate key, okay? All right, so what questions do we have about that idea? If you want to see the indexes, you can actually just say show index on customer, and it'll show from customer, so like I said, show index from customer, and it'll show you that it has the primary key. It also has a foreign key constraint, which I'm going to remove that, and we're going to re-add it in a second, because I want to show you how to build that. So ignore this third one here. But the primary key, we already knew about that one. And then we just made this index here that's a unique index. And if you happen to have taken data structures and algorithms, you might recognize this data structure here called the B tree. Okay, if you don't know what that is, don't worry about it. But that's just the structure that this is in, and that's how it's accessible in the back end. It's just back end stuff, how it's stored. It makes it more efficient. Okay, but we can see these indexes right here. We can also remove them, right? Drop index customer name index on customer table, and goodbye index, right? I'm going to nuke the database. We're going to move on from indexes in a second, but I want to ask a couple questions about it. Thing number one, why would an index matter? Who cares? We talked about speed. Why is the speed that important? I mean, if I'm running a query and I want to run it and then go get some lunch and come back and it's still running and I do some other stuff and I get it, well, who cares, right? Why does it matter that much?
Information right there.
Sometimes you need the information quickly. Sometimes the query doesn't take 20 minutes while you run out and come back. It takes 10 hours, right? Sometimes if you're connected with a web page and it's the PHP code or whatever language you're using is doing something in the database and it has to finish that before it can deliver the web page up, well, that's an awesome experience, www.whatever.com, and it takes an hour to load the data before it can even send the page to you, right? Speaking of www.whatever.com, you guys familiar with this website? Is it Christmas.com? No. That's one of my favorite sites ever. No, that's not mine. I don't know who owns that site. I've never looked at it on Christmas Day, but that's what it says. 364 days a year, yeah. So anyway. Yes, that's exactly. At 11:59, right before it changes.
Is finals yet?
Yeah. Oh, yeah. Funny. All right. Anyway, so indexes can make a huge difference. And what's the angle? I keep saying this is all about being a control freak. What's the control freak angle for this? Keeps you more organized, keeps the data more efficient, for sure. And sometimes being a control freak is just having to not be around chaos, right? It's the old quote from Lincoln. Give me, I don't remember the exact numbers, but give me 6 hours to chop down a tree and I'll spend the first 5 sharpening the saw. I probably got the numbers wrong, but that's the general idea of it. I'm similar to that in my work environment. You give me 8 hours to write code, I'll have to spend the first 4 hours cleaning my office so I can focus. If my office is a mess, which it usually isn't. But I can't have anything on my desk, which is why these things are only from class today. At the end of the day, when I go home, those will be deleted. My desktop stays empty, and my physical desktop stays empty. So sometimes it's just a mental thing with our brains, depending on how you're wired. But also, it's a thing with the database. We want the database to be organized and efficient and clean, right? All right, so moving on. If you want more details, the code I just wrote is all right here. You can take a look at it. But let's talk about some other things dealing with data integrity, constraints particularly. What is a constraint? Just in the human world, what's a constraint?
It's like a simple you need to follow, like a base.
Yeah, just some rules that you're bound by, right? You're constrained by, hence the name, right? Yeah, just simple things that you're bound by. So what are some rules or constraints that we might want to put on a database? We've already used some of them, believe it or not. You may not recognize them as such, but we have done it. So data types is one thing, right, where you can constrain. For example, maybe I only want to allow actual numbers, so we can use an integer data type, right? Like right now, if we look at, say, the rep table, notice the rep numbers are actual numbers, right? But that's actually a char data type, right? Well, maybe we want to constrain it to where it can only be a number. Like right now, I can make a rep number. I can totally insert into rep num values RR. That's my rep num's ID. That totally works, no problem. Because it's a char type, right? Well, we could put a constraint on there saying, no, you can only enter a number, right? Maybe. And what's the constraint? You just change the data type to int, the end, right? You don't have to do much there. There's also a data type called an enum, right? So let's look at the TAL database here. So look at the item database, the item table. We have the category there, right? It's a char 3. But if you look at them, all I want is select distinct category from item. There's only 3 categories, right? So we can create the data type for category to be what's called an enum, which stands for an enumeration, that can only allow those 3 values. So let's change the data type, right? We alter the table called item. We modify the column called category. And instead of setting it as a char or whatever, we set it as an enum, and we put in the parameters that are allowed. So it can only be a game, a toy, or a puzzle. That's it. That's all it's allowed. And there we go. We just created an enum for that. So look what this means. Describe item. And now its data type is enum. That can only be game, toy, or puzzle. What does that mean? Well, if we insert into item, and we're going to put in our favorite little robot here, BB-8, and it's a droid, 3 on hand, then he's category robot, and then he's storehouse 2, and he's $99. Now, what's your vote on what's going to happen when I hit enter? Assuming I didn't typo or anything, assuming I got the syntax correct. Okay, an error. Any other votes? That's what I wish we got. That's what you'd think we should get, but no. Oh, we do get an error because I spelled something wrong. This is not, this is me not putting the word values right there. Man, did I get drunk before I came to work today? Man, no, I don't drink, so it wasn't that. Holy crap. So insert into item values. Now, we don't get an error when we run. That was the point I was trying to make. That was totally anticlimactic. So what happened though? It didn't give me an error. Did it insert the record? That's the next question. Select star from item. And what do you think? You got to vote and say no, yes. Close. It does insert it, but it leaves that field blank, which is just no good. It's just not good. When it does that, my thought is, why even have that as an option, right? I don't want you to, it has to be one of these three names, or you can just put nothing. No, I want to restrict you to these three names, right? So this is not necessarily the best option, okay? We can look at some alternatives to this. One particular alternative, typically most of the inserting and stuff that I do in a database happens in PHP code or some other language, right? And so, or it's some front-end interface that I built where it's all point and clicky, right? Click from the drop-down menu of only game or toy or whatever, and so it can't choose anything else, right? So that's typically how I do it. But if it's going to be something in the back end like this, there are some things that we can do to protect it a little bit, all right? And that's where we get into what's called a check. You can do a constraint that's called a check, all right? So here's how a check works. I can put a constraint on a field that has a check that says, check to see if the value is within this parameter, right? So we can do this. It's the same situation, right? Say the thing you're gonna do, say the thing you're doing too, that whole pattern, right? So let's do, just to start with, we're not gonna mess with the category. Let's look at the number that's the storehouse, for example. We only have storehouse 1, 2, and 3. We don't have a storehouse 0. We don't have a storehouse -1. We don't have a storehouse 4. We have a 0, 1, and 2, or 1, 2, and 3. So do we have what's the data type here? Storehouse is a character 1, right? Well, we can make sure, like right now, if I wanted to put storehouse Z, I can do that. Maybe we want to make sure that doesn't happen. So one thing we can do is alter the table called item, modify column called storehouse, and set it to an int instead of a char, right? And now we won't be able to enter anything that's not a number at least, right? But I can still easily insert into there. We'll do item. Let's just pull that BB8 one and change a couple things on it. So BB8, we now have BB9, or B98, whatever. And then I'm going to put it in, is that the storehouse right there? Storehouse -1, right? That's no good, but it will enter it because we didn't restrict it. So now I have -1 there. That's no good, okay? So I'm going to delete that record because I'm about to create a check on there that will prevent me from entering a negative value. But if there's already a negative value there, when I try to build the check, it won't let me build it, right? It'll give me an error saying, no, you can't build that because you have data that's going to violate the check. So I'm going to delete that record. So now let's build this constraint. It's called a check, right? So how do we build this? We're going to alter the item table. And now I'm not actually going to be modifying a specific column. Constraints are actually applied to the entire table. Just like when we create a table, if we use the syntax of putting the primary key at the bottom and put primary key in parentheses and put the value, right? That's a constraint on the table. It's not really a field-based constraint, even though it is constraining a field. So we're altering the table and we're adding a constraint to the table called, let's call it storehouse, whatever, just storehouse constraint or something like that, okay? We're adding the constraint, and then the type of constraint is what follows. It's a check constraint, okay? So alter the table called item, say the thing you're gonna do, say what you're doing to, say its name, add a constraint, say what you're gonna do, add, what are you adding a constraint, what's its name, STH_C. Now, what are some parameters about it? Well, it's a check constraint. And the check constraint says storehouse must be greater than 0. And I can throw in here storehouse less than 4 if I wanted to. Put them both in there. Now it can only let me put 1, 2, and 3. Could I put 1.2? it's an integer, so I can't. It won't let me put in 1.2. So I've already constrained it to force it to be an integer, and now I've constrained it to literally only be the numbers 1, 2, or 3, right? Cross your fingers, hope for no typos, and yay, I got one right today. Okay, so now describe item, and you don't see anything that looks any different here, but if I try to insert, so let's go back to that BB98 with the -1, it's going to tell me I have a constraint problem on the -1 there. Constraint STH failed for that. So there's lots of ways you can do this kind of stuff to protect the data and prevent some rogue new person from getting in there and screwing stuff up. Hopefully you've given them the safe privileges so they can't do it anyway. But just in case, eventually they're going to have their first day where they're allowed to insert stuff or whatever, and you feel like they've been trained well enough, and they're going to screw up. So you got little things like this to prevent it. Okay, foreign key constraint. Take a look at customer here. In the customer table, is there a foreign key? I'm warning you, this is kind of a trick question. So I hear vote for yes, it's the rep num. And the reason this is a trick question is because in all of our brains, that's the foreign key. The database doesn't know this, right? We just know it as the programmers of the people who wrote the database, who built it. We know that's the foreign key that links to the primary key in the rep table. We know it. But feel free to insert into customer num, rep num, values, I don't know, a customer called 888, and a rep num called 99, which doesn't exist, but it allows it to be in there, right? There is this 888 person represented by rep 99. That's no good because who's rep 99? There's RR, but there's no 99. That's no good. So we want to constrain that to allow it to only put in numbers if they're actually in the original table, the primary table, okay? That make sense? So we're going to use a text editor here so I can catch my typos before I paste them in. So we need to alter the table called customer, right? And then we need to add a constraint, right? We're not modifying a column. We're adding a table-wide constraint. So add constraint. We'll call it, customer rep, whatever, okay? And what kind of constraint is it? It's a foreign key constraint. Yeah, very good. So foreign key constraint. It's a foreign key constraint on the rep num. So we're not quite done yet, but let's just make sure we understand what we wrote so far. Say the thing you're going to do, say the thing you're doing it to, say its name, alter table customer. Now moving on, say the thing I'm going to do, add, say the thing I'm doing it to, constraint, say its name, it's called C_R, whatever I want to call it. And then I'm going to give it the details of what kind of constraint is it. It's a foreign key constraint being applied to the rep table, or to the rep num field, I should say. And that rep num, we need to tell it, what does it reference? Well, it references did I spell that right? References, there we go. It references the rep table and its rep num field. That's a big mouthful there, but does that command make sense? What's going on there? All right, so now if I add that, now it's going to give me an error when I try to build it. Why? Because I've already violated the constraint even before I built it, right? So it's going to give me an error, right? I can't do it because I have this problem, so I'm going to delete that one record right there, 88, right? So delete from customer where customer is 888. Now I'll redo that constraint. Works just fine. And now let's try to insert that customer again, the exact same customer. If I try to insert it now, it should give me an error because it's violating my constraint. Cannot add or update a child row, a foreign key constraint fails. Right? And it gives you a very clear error what's going on, even tells you the name of the foreign key constraint and everything. Okay, any questions about what we looked at here?